Namaste and welcome to Apna Gurukul Maths. We are discussing the chapter number 2 NCERT Mathematics Polynomials. We have already discussed about the introduction of this chapter. Today we are going to proceed for the first topic of this particular chapter, that is called as zeros of polynomial. Now, what do we understand by zeros of a polynomial? They are also called as roots of a polynomial. What does that mean, and how do we understand that? Let's get into the topic. So first of all, are we clear with the definition of polynomials? Polynomials are algebraic expressions where the variables are raised to the power. What kind of powers? Whole numbers. Absolutely correct. And obviously we have several terms in that. Even we have constant polynomials. Are we clear with degree and types of polynomial? Degree is the maximum power to which it raised to. And types of polynomials we have divided on the basis of terms and as well as on the basis of degrees. The third point, are we clear with value of an algebraic expression? What do we understand by that? You might have studied about this in class 8. If you have forgotten, let's quickly take an example. Suppose you have an algebraic expression 2x plus 5. The value of this expression is, suppose I give a number to x. X is a variable and we can give any number to that. Suppose I give x equals to 5. So according to the value of the variable, wherever the expression goes, that is the value of expression. So x equals 5. So you substitute in this. So 2 times 5 plus 5. So obviously Bodmas rule, 2 times 5 is 10 plus 5 equals 15. So this 15 is the value of this particular algebraic expression. I hope by this you are able to recall what do we mean by value of algebraic expression. Now, do we understand what's the meaning of values of a polynomial? If not, that is what we will start this video with. Let's begin. Value of a polynomial. So value of p of x at x. Right? What is the meaning of that? Over here, p of x is the polynomial. We obviously learned that we denote the polynomial as p of x. Right? P of x equals some expression in the term of a polynomial according to the definition. So we get a polynomial, and p of x is the denotion. So if we, instead of x, we give some value or some number, let us take like that. Instead of x, if we give some number, whatever answer we get after solving the polynomial, that becomes the value of polynomial. So let's try to understand. P of x equals 5x square minus 2x square plus 3x minus 2. This is the polynomial. Now I want to find what is the value of p of 1. So p of 1 is equals to, I'm sorry, I wrote minus 1, it should be plus 1. So p of 1, what is the, how do we substitute it here? Wherever we have the value of x in this polynomial, wherever we have x in this polynomial, we will substitute that by 1 because we are finding p of 1. So that becomes 5 times x square. Instead of x square, we'll get 1 square minus 2 1 square plus 3 times 1 minus 2. So 1 square is nothing but 1. So 5 times 1 is 5. Minus 2 times 1 is 2. Plus 3 times 1 is 3 minus 2. Yes? So 5 minus 2 is 3 plus 3 minus 2. 3 plus 3 is 6 minus 2 is 4. So the value of p of 1 in this particular polynomial. Now, p of 1 equals 4. Now, this is only for this polynomial. Don't think in the manner that wherever we have p of 1, every time the value will be 4. No, only for this polynomial. If the value of, if we calculate the value of polynomial at p of 1, then we get the value as 4. Yes, let's try to find out what is p of 0. I'm sorry. Let's try to find the value of p of 0. What will we get? So p of 0, if we try to find it out, p of 0, what is the meaning of that? Wherever we have the value of x, we will substitute it by 0. So p of 0, I'll calculate it here. That's better place. P of 0 equals 5 times 0 is 0, because 0 square is nothing but 0. Minus 2 times, we'll substitute 0 here, so 2 times 0 is also 0, plus 0 minus 2. So p of 0, the value of p of 0, this implies p of 0 is equal to minus 2, because 0 minus 0 is 0 every time 0, so we are not worried about that. Yes, so p of 0 equals minus 2. So now I understand that you got a little bit of knack of how to calculate the value of polynomial. Now we have one more polynomial here. Let's try to find what is now what. Keep observing very patiently. We are trying to, when we are trying to find the value of values of polynomials, we will observe what is the value of polynomial over here. Then we will go to the major topic what we started with, 0 of polynomial. Right? You can see we are calling value of polynomial. Have we got a value as 0 yet? No, right? Is it possible that we get a value of polynomial as 0? We will try to find it out, okay, with this example. So q of x equals x square plus 2x minus 3. Let's try to find the value of q of 1. So q of 1, now you can tell me how will we proceed. Substitute, instead of all the value of x, substitute it with 1. So it becomes 1 square plus 2 times 1 minus 3. So what we get, 1 plus 2 times 1 is 2 minus 3. What do we get? 2 plus 1 is 3 minus 3. That is equal to 0. So the value of q of 1 is 0. That means the value of polynomial can be 0 as well. What is the value of q of minus 1? You can quickly calculate q of minus 1. I will calculate it a little bit faster. Q of minus 1 is minus 1 whole square is 1, minus 2 times minus 1 is minus 2, and then minus 3. So 1 minus 2. 1 minus 2 is minus 1 minus 3, you get it as minus 4. So q of minus 1 is minus 4. Similarly, you can calculate the value of q of minus 3. So when you calculate the value of q of minus 3, you get it at, instead of x, we are substituting minus 3. So minus 3 squared is positive 9 plus 2 times minus 3. 2 times minus 3 is minus 6. And then minus 3. So minus 6 minus 3 is minus 9. So 9 minus 9 equals to 0. So what do we observe? That 1 and 3, the value of 1 and minus 3, when you substitute in the polynomial the values of minus 1 and minus 3, when we get the value as 0, that is called as 0 of polynomial. I will repeat. Instead of x, we substitute such a number such that that numbers makes the polynomial's value or the value of polynomial as 0. Lot of times value is being repeated, so please listen to me carefully. I'm trying to avoid the much usage of value. Let's focus here. We have some number for x, right? We give some number to x, and if that number leads the value of polynomial to be 0, that particular number is called as 0 of polynomial. Is that understood? In this case, since q of 1 and q of minus 3 is 0, we say that 1 and minus 3 are zeros of polynomial. I'm sorry, here it should be zeros of polynomial, because there are two, right, zeros of the polynomial q of x. Now this 1 and minus 3 is only zeros for this particular polynomial q of x equals x squared plus 2x minus 3. I hope that is very much clear. Now value of polynomial, let's try to understand it in a little more detail. So p of x equals x minus 1. If we try to find the value at x equals 1, so what do we write? P of 1, instead of x we write 1. 1 minus 1 equals 0. So p of 1 will be 0. That means over here 1 is the 0 of polynomial x minus 1. Yes. So now the question arises, what is the 0 of a constant polynomial? What is the 0 of a constant polynomial? Is there any possible value? Constant polynomial, suppose 7, right? 7x to the power 0. Is there any possibility that we put, instead of x, we put a number such that this value becomes 0? That is what is expected, right? Is there a possibility? It is never possible. Because no matter what value you give to x, x to the power 0 is always going to be 1, and 7 times 1 is always going to remain as 7. So this equality is never true, and that is why there is no zero of constant polynomial. I repeat, there is no zero for a constant polynomial. I hope that makes sense very clearly. I'll repeat it once again. Suppose 7 is a constant polynomial. 7 is nothing but 7x to the power 0, and if it has to be a 0, means if if we have to find the zero of polynomial, we equate it to 0, because that is what we want, right? We want the value of x such that the value of polynomial becomes 0. Yes. So is there any possibility that we can put a number to x such that it becomes equal to 0? No, right? Because whatever number you put in place of x, x to the power 0 is always going to remain as 1. 7 times 1 is always 7. It can never become 0. That is why there is no 0 of a constant polynomial. But when it comes to zero polynomial is nothing but 0. Zero polynomial can be written as 0x to the power 0. Now in this case, no matter what number you give to x, any possible real number, every time this will go to 0 itself, because 0 multiplied by any number is 0. That is why each and every real number is written as written by a bold letter capital R, or when you are writing it in your notebook, it is written as, you can write it like this. This is written as the denotion of real numbers, right? So every possible real number is a zero of a zero polynomial. Okay, or you can, if 0 is getting confused, is a root of zero polynomial. Now root and 0 means the same thing. Okay, so now check if 2 and minus 2 are zeros of x plus 2. Let's check it out. So 2 and minus 2, we have to check it out. So instead of x, we substitute the x plus 2 is the polynomial. So instead of instead of x, we substitute 2. So 2 plus 2 equals 4. Obviously, 2 is not a zero of polynomial. Let's check minus 2. Instead of x, we substitute minus 2. Minus 2 plus 2 becomes 0. So this polynomial, for this polynomial, minus 2 is a zero of the polynomial. I hope that is very, very much clear. Now, what are the observations about zeros of polynomial? That a polynomial can have more than one zeros. As we saw in this particular example, q of x equals x squared plus 2x minus 3, we had x of 1 as the 0 and q of 1 and q of minus 3 as the 0, right? More than one possibilities are obviously there. Zero of a polynomial need not be 0. Yes or no? Over here, we got 1 and minus 3 as 0 of polynomial. So, it could be 0. It is not a compulsion. So 0 of a polynomial need not be 0. Obviously, 0 may be a 0 of the polynomial. It's always a possibility that 0 may be a 0 of the polynomial, or we would rather say root of the polynomial. Now, when we talk about linear polynomial, as you saw x plus 2, there is only one 0 possible. You try to find it out, there will be no other 0 possible for a linear polynomial. So only one 0 is possible for linear polynomial. Now, what is a linear polynomial, my dear friends? Linear polynomial is a polynomial with degree 1, right? So let's try to now prove why does a linear polynomial it has only one 0. The proof is little smaller and it's little beautiful. So what is the standard form of a linear polynomial? It is written as p of x equals ax plus b. Okay, where a and b are constants, and obviously a is not equal to 0. What is the reason? If a is 0, what are we left with? B, and b is a constant, so it becomes a constant polynomial, not a linear polynomial. I hope that makes sense. So this is the statement. Now, if we have to find the zeros of the polynomial, what is the method? We want this particular polynomial, the value of this particular polynomial, to go to 0. Yes or no? So that is why we equate it to 0. When we equate it to 0 and we want the value of x, right? So we take this b to the other side, we get minus b, and then a to the other side. So we get x equals minus b by a. So no matter what kind of linear polynomial you have, if you know these two coefficients a and b and constant term and the coefficient of x, we will always be able to find the zero of the polynomial or root of the polynomial, which will be minus b by a, and there is only one possibility, and that's how we say linear polynomial always have one and only one zero. Okay, now we are stressing on linear polynomial because when we start remainder theorem and factor theorem, we'll have lots and lots of things related to linear polynomial. That's what. So let's solve a few questions. So q of z equals 5z square minus z plus 10. So we will try to find the value of q of 1 and q of 2, and we'll try to verify if they are zeros of the polynomial. So q of 1, let's quickly find it out. Q of 1 will be, instead of all the values of z, we will substitute 1. So this becomes 5 times 1 square is 1 minus, instead of z we are substituting 1 plus 10. So now that becomes 5 times 1 is 5 minus 1 plus 10. 5 minus 1 is 4 plus 10. That gives us 14. So that means q of 1 equals 14. So can we say that 1 is a zero of polynomial? Absolutely not. So 1 is not a zero of the polynomial. Let's try to understand what is the value of q of 2 and then verify if it's a zero of the polynomial. Is polynomial q of z. So q of 2, let's quickly go through that. 5 times 2 squared minus 2 plus 10. So 5 times 2 square is 4 minus 2 plus 10. That gets us to 5. 5 4s are 20 minus 2 plus 10. Obviously 20 minus 2 is 18 plus 10, 28. So even q of 2 is not equal, not giving us the value of 0. So over here, the value of polynomial we find out q of 1 is 14 and q of 2 is 28, but we are not able to find the zeros of the polynomial. Let's try to understand how we find the zeros of polynomial. We have already learned something over here, that if you have a linear polynomial, the zero of polynomial is nothing but minus b by a. So let's quickly verify the formula as well as how do we find a zero of the polynomial. Suppose we have the linear polynomial 3x plus 1. So p of x, we have it as 3x plus 1. Yes or no? So I will quickly make a line over here such that you don't have a confusion in understanding. Yes. And let's change the color. So p of x equals 3x plus 1. Now, once we are trying to find the zero of polynomial, we want the value of polynomial to be 0. Yes. And then we have to identify what should be the possibility of x. Yes or no? So that means p of x equals 0. That implies 3x plus 1 equals to 0. So 3x equals to 0. 1 goes to the other side, it becomes minus 1. 0 minus 1. Yes. So 3x equals 0 minus 1 is minus 1. So 3 is in multiplication with x. When it goes to the other side, it becomes division. So x equals minus 1 divided by 3. So x is equal to minus 1 by 3. Yes or no? I hope that makes really nice sense. So over here we have found x equals minus 1 by 3. Quickly verify that if we substitute the value of minus 1 by 3 in p of x, whether we are getting the value of this polynomial as 0. So we have 3x plus 1. Now we are going both ways to be a little more clear. So 3 times, instead of x we substitute minus 1 by 3 plus 1. So this 3 and 3 gets cancelled because they are a multiplication. So we left with minus 1 plus 1. Minus 1 plus 1 is 0. That means the process we followed is absolutely correct to find the value of the to find the zero of a polynomial or root of a polynomial. Yes. So quickly the formula we discussed was x equals minus b by a. Whenever we have minus b by a, the polynomial is in the form of ax plus b. So where b is the constant polynomial. So b is over here is plus 1. So x equals, minus sign is already there. So instead of b, I substituted 1. A is the coefficient of the x variable. So over here it's 3. X equals minus 1 by 3. So as you can see, there are different methods to find the zeros. Either you can equate it to 0, you can use the formula, or you can use trial and error. Why to go for trial and error? It's a little bit clumsy every time. Trial and error is something I would never recommend for you to do. Now 9x plus pi, if you have to find the 0 of q of x, just it would the value of x should be minus b. So over here minus b by a, that is equals to minus, instead of b we have pi over here, pi over 9. So the 0 must be minus pi by 9. Over here it has asked us to find the value of x at pi. Let's try to verify if it's a 0 or not. I'm very much sure it will not be, and I hope you understand why am I saying that. So let's try to, 9x plus pi is the equation we have. So instead of x we have to substitute pi. So 9 times pi plus pi. So 9 pi plus pi, 9 pi plus pi is 10 pi. Is 10 pi equal to 0? Not, right? So that means pi is not the 0 of polynomial. Over here, whenever, now this type of question is very important for us to understand. Whenever it's like y plus 1 multiplied by y plus 2, it's already in the factor form, linear factors. We have already learned it when we were learning the identities. Once again, we will learn it in the 5th part, where we focus on identities, that what are factor part and what are the expanded part. So over here, we both are linear factors, right? Linear expressions. They are both are multiplied to each other. So over here, as you can see, r of y is given to be y plus 1 multiplied by y plus 2. Now, if we substitute minus 1, so minus 1 plus 1 times y plus 2, or we can, instead of y we have substituted minus 1, right? So this becomes 0 times minus 1 plus 2 is 1. So 0 times 1 is 1. That means 1 is a 0, minus 1 is a 0 of the polynomial. Or if we substitute the value of 2, so let's try to understand. 2 plus 1 and 2 plus 2. So 2 plus 1 is 3 multiplied by 4, which is equals to 12. That says that 2 is not the 0 of polynomial r of y. Now, my dear friends, just observe one very beautiful thing over here. I will erase this part and quickly explain it to you. What do I mean and why am I stressing on this point? Okay. Yes, quickly change the color of the pen. Now, when we have y plus 1 times y plus 2. Now, when we are trying to find the value of 0 of this polynomial, this must be equal to 0. So what do we understand here? There are two numbers. Y plus 1 is nothing but a number, right? When we substitute the value of y. Or you can understand there is two expressions which when multiplied to each other resulting in a 0. So let's suppose a different scenario. If we had x times y equals 0, what is the meaning of that? Either x is 0. If x is 0, 0 times y is also 0, or y is 0. Or the third possibility is x and y both are 0. In all these three situations, we are getting this particular equation to be true. Yes or no? Xy equals 0. And at the same time, can we say that y can never be 0 in xy equals 0? Can we possibly say that y cannot be 0? We cannot say that because there is a possibility y could be 0. Can we say that x can never be 0? We cannot say that. Similarly, over here, instead of x, we have a little bigger term y plus 1 and y plus 2. Both are multiplied to each other and the answer is coming out to be 0. So what is the meaning of that? Y plus 1 is equal to 0 also. This is also possible, and y plus 2 is also equal to 0. So y should be 0 minus 1, that gets down to minus 1, y equals minus 2. So they both are zeros of the polynomial. So whenever you have the polynomial in this form, it's very easy to find the zeros of polynomial. Just equate these separate linear factors to 0. That's all we get. So Lx plus m equal Lx plus m is the polynomial. We have to find its value x equals at x equals minus m is the constant term. So constant term is in the numerator and the coefficient is in the denominator. That is what the formula says, right? Minus b by a. That means they are. This is the zero of the polynomial. Now over here, very quickly we'll solve these problems. So p of x equals x to the power x plus 5. So what is the zero of polynomial? Minus 5. What is the zero of x plus 10? It will be x minus 10. I'm sorry, it will be plus 10. Plus 10 minus 10 is 0. What will be the zero of polynomial? Y plus pi? It will be minus pi. What you can use the formula. I'm doing a little bit fast over here. What is the zero of this polynomial? Obviously x must be equal to 0 because 0 b is not equal to 0. B is a constant here. So if b is not equal to 0, x must be 0 in order to, obviously bx equals to 0, right? That is how we find the zeros of polynomial. So if b is not 0, x must be 0 because it's already given, right? So x must be 0 and 0 is the zero of polynomial. We observed, right? 0 may be the zero of the polynomial or root of the polynomial, to be more precise. 3x, obviously the value of x equals 0 and 0 is the 0 0 is the zero of the polynomial or root of the polynomial over here. So 3y plus 1 equal to 0. We'll quickly solve it. That is how we find the zero of polynomial. So 3y equals 0 minus 1. So 3y equals minus 1. Y equals minus 1 divided by 3. 3 is in multiplication. When it goes to the other side, it becomes division. So minus 1 by 3. So y becomes equal to minus 1 by 3. Similarly, if we solve this, the value of y means this value of 0 of the polynomial will be plus 4 by 2 because 4 minus 4 goes to the other side of the equation. It becomes plus 4 and you get y equals 2, right? I hope the zeros of the polynomial, the concept is very much clear for all of you. With this, that's it for this video. Now further we will discuss about remainder theorem, factor theorem, very important theorems and very interesting as well. Thank you so much for your patient sharing. Thank you so much for being with Apna Gurukul. See you in the next video. Until then, keep smiling. Jai Hind.